Now we'll see a problem in quantum mechanics. The problem is evaluate Einstein A coefficient for the transition from state 310 to 200 state. I have taken this problem from Quantum Mechanics by Aruldas. So Einstein A coefficient is from state m to n is equal to 16 pi epsilon naught alpha omega mn cube divided by 3c squared and modulus of expectation value of r squared. So here the expectation value is with respect to the state 310 to 200. So it is an R vector, so it has a component x, y and z. So if you take in polar coordinate, spherical polar coordinate, x equal to r sin theta cos phi and y is equal to r sin theta sin phi and z is equal to r cos theta. So if you consider the phi part of the integral, if you consider for x and y, that will be vanishes, so that the expectation value of x, expectation value of y is 0. So the non-vanishing term is the expectation value of z. So it is uh, expectation value of r cos theta, that with respect to the state 310 and 200. So the wave function for hydrogen atom in n is equal to 3, L is equal to 1 and M is equal to 0 is, that is I310 is R31 of R, Y10 of theta and phi. That is, we can write the wave function in terms of radial and angular part. And radial part is in terms of N and L and angular part is for L and M. So it is R31 of R, Y10 of theta and phi. So if you take the radial wave function of hydrogen-like atom, RNL of R is equal to minus of 2Z by NA whole power 3, N minus L minus 1 factorial divided by 2N, N plus 1 factorial cube whole power half into e power minus ZR by NA and 2 ZR by NA whole power L and L 2 N plus L and 2L plus 1 of 2 ZR by NA. So if you substitute the value of N is equal to 3 and L is equal to 1, and we can get the L function L for 3 of 2R by 3A, and also for hydrogen like atom Z is equal to 1, and also this L PQ of rho is equal to, you have this formula, that is Q factorial divided by Q minus P factorial e power rho d power Q divided by d rho power Q e power minus rho of Q minus rho. So here Q is 4 and P is 3. So if you put the value and make a differentiation, then we can get it is 4 factorial minus 4 plus 2R by 3. Now you substitute this value, then R31 is 2 by 3A whole power 5, 1 divided by 6 into 4 factorial whole power half e power minus R by 3A into R 4 minus 2R by 3A. And also the spherical harmonics Y10 of theta and phi is 3 by 4 pi square root into cos theta. So if you substitute all this, we can get psi 310 is 2 by 3A whole power 5, 1 by 2 pi into 4 factorial whole power half e power minus R by 3A into R 1 minus R by 3A into cos theta. The derivation for the spherical harmonics, I made it in a separate YouTube also. Next, you have to calculate psi 200. Similar to the previous case, you have to find out this R20 of R and Y00 of theta and comma phi. That Y00 of theta and comma phi is square root of 1 by 4 pi and R20 of R is that is z by a whole power 3 by 2, 1 by square root of 2 e power minus zr by 2a into 1 minus zr by 2a. Here we have to put z is equal to 1 for hydrogen atom. So psi 200 is 1 by 2a whole power 3 by 2 into 1 by square root of pi e power minus r by 2a into 1 minus r by 2a. So you know the value of psi of 310 and psi 200. Now you substitute r z cos theta, and also instead of d tau you have to put r squared, that is integral from 0 to infinity r squared, um, r squared sin theta dr d theta d phi. So theta varies from 0 to pi, and phi varies from 0 to 2 pi, and tr varies from 0 to infinity. So if you separate r value and theta value and phi value, and if you integrate over theta phi r, and then we can get. So for r integral from 0 to infinity r power n e power minus a r dr is n factorial divided by a power n plus 1. So if you substitute our case, then we can get it is 2 4 factorial divided by 5 by 6a power 5 minus 4 by 3a 5 factorial divided by 5 by 6a whole power 6 plus 1 by 6a squared 6 factorial divided by 5 by 6a whole power 7. Similarly, if you do it for theta, then you are getting it is 2 by 3. And for phi, it is 2 pi. So you substitute all the values for the integral, then you can get finally it is 1.7695 into a. So now you need that square. So it is square of the expectation value of R is 3.13 into A squared. So omega, the angular frequency is equal to 2 pi nu mn. So nu 3 2, that is here n and m is 3 and 2. So it is nu 3 2 is E3 minus E2 divided by H. So you know the value of En is equal to minus 13.6 Z by n squared. Z is 1. And here substitute n is equal to 3 and n is equal to 2 and take the difference. Then you can get it is E3 minus E2 is 3.024 into 10 power minus 19 joules. Now you substitute all this value, then omega 32 is 2.87 into 10 power 15 per second. So now you substitute this in the Einstein A coefficient, and here omega it is alpha is fine structure constant, it is 1 by 137, and epsilon naught is permittivity of free space, and A is C is the velocity of light, and A is the Bohr radius. It is 0.53 into 0.53 angstrom. So substitute all these values, then we can get the Einstein A coefficient is 2.5 into 10 power minus 3 per second. Thank you.